Okay, so this time I'm going to do 2 videos on the same type of transformation because unfortunately a lot of what I normally do and normally have you do is like actually turn grid paper, and that may not, I realize that may not be possible. I think I'll give you that option if you can print or that sort of thing, or if you want to do it on paper and kind of turn it, that's fine. But the IXL will not let you actually turn the grid, so there are also some rules I'll give you. So first of all, we're going to do transformations. Again, another type of transformation, and this one is rotations. Okay. Now, what this basically is, a rotation is basically turning the grid to, like, basically just rotating the figure. Okay, on a certain number of degrees. Now, we will be doing only about the origin. So that's that 0, 0 middle coordinate, meaning kind of is almost if you have like a point here, your turns will be based on that point kind of staying at the same spot. Well, that's kind of cool. So anyway, so like when you turn the grid and you rotate it literally, it would be in the same spot. Okay, that origin point would be in the same spot. Okay, so let's just do kind of a reminder about degrees. Okay, so different angles of rotation here. So I'm going to kind of give you a grid here. Okay, and rotations occur in 2 directions, either clockwise or counterclockwise. So we'll start just kind of with a rotation that's clockwise. Or sorry, we're going to start with counterclockwise. So like let's say I had something here. So if I were going to go 90 degrees, this would be like 90 degrees clockwise. Excuse me again, counterclockwise, think about a clock. And okay, so that would be 90 degrees counter. This would be if I took a point here and I went all the way here, that would be 180 degrees counter. Okay, then if I went all the way from here past the 180 to approximately that spot, so turned it that whole way, this would be 270 degrees counter. And although we could list the last one, which I will, but there's not a whole lot of point because it's a full circle situation. So you kind of are just back at the same point if you go 360 degrees. So I'll write it, but yeah. Okay. So that's kind of how it goes counterclockwise. Now, if I look at another grid, since it might get a little confusing. All right, so here's this kind of same grid, but now this time I'll rotate, or I'll look at what it would look like to have a rotation clockwise if I started right here. So here would be 90 degrees clockwise. Oops, there you go. Clockwise. So if you're going the way the clock goes, so when the hand on the clock, the minute hand or the second hand goes, it goes this way, or even the hour hand. Okay. And then this one would be the 180. Okay, and then 270. Okay, and it's not really necessary to do 360. Now, what you might notice is that this spot here, the 90 degrees counter, which had you kind of, if we started our first in the positive X direction, it had you at the positive Y direction, is the same as where you are for 270 clockwise. So one thing to notice is we could say like equivalent rotations. Okay, so 90 degrees counterclockwise is the same as 270 degrees clockwise. Okay, and that is the same as 180 degrees counter is the same as 180 degrees clockwise. So you'll notice actually with 180 we wouldn't really need to tell what way we went, because turning 180 either direction would be, and you'd end up in the same spot. It's kind of like if you turned around so your back was to someone, that's a 180 degree turn. So that's kind of the one way to think about kind of these turns. Just think of it as turning, turning, and turning, okay? So then this third one that you'll need is 270 degrees counterclockwise is the same as 90 degrees clockwise. Okay, and I'll kind of mark that. Okay, so here were the two 180s, and the last one in orange were the 90 degrees clockwise and 270 degrees counter. So you'll notice we ended up in the same spot. I tend to personally still actually kind of rotate it whatever the directions say. Okay, so now we're going to start with rotations of just a single coordinate just to make it simpler, and then I will do another video and kind of make them both available with the practice so that you can see rotations of full figures as well. Okay, so I'm going to start with kind of this grid paper. Now I'm not going to tape it down because I personally prefer actually to move the grid itself. Okay, so let's say I start with a coordinate, I don't know, in the first quadrant here. Okay, so let's say I start with a coordinate 3, 9. Okay, so first of all, that coordinate is 3, 9. Okay, now I'm going to move it in rotations. So the original is 3, 9. Okay, now I'm going to move it. I'm going to do this one counterclockwise. So I'm going to move it in all 4 of the ways. So first of all, 90 degrees counter would be to go this way. Now what I prefer to do is I kind of think of this right now. This is the positive y, and this is the positive x. I like to turn the actual paper because this has always been a little tricky for me personally to visualize what's going on. So I actually turn the paper, and you'll notice I just took it where this had been up here, and now this is going to move that 90 degrees, okay? So you're going to move that 90 degrees, so now that is up here. Now, I consider this now as this point here now is no longer where it was, right? So now think of this as the negative x, and this is the positive y, and think about what that coordinate would actually be then. So you'll notice it went left 9. So the new coordinate would actually be, so under 90 degrees counterclockwise rotation, the new coordinate would actually be over here at negative 9. Okay, and then up to positive 3. So negative 9, positive 3. Okay, so now what I do, when I normally do these, I like to move it back then. And then I'd say, okay, negative 9, positive 3. So this would be my 90 degrees counterclockwise rotation. Okay, so that would be my 90 degrees counter. Now, I'll kind of give you a formula for what you can also use with all of these. Actually, why don't we do that right now? So you'll notice that the 3, 9, this kind of just flipped that. So, and the 3, and this 3 here, so the 3 that was the x is now the y. The 9 that was the y is now the x, but it's negative. So for a 90 degree counterclockwise rotation, you're going to go from x comma y to, so this is kind of like your rule, okay? And if you aren't able to flip and turn the paper around, this may be how you kind of have to do it. X comma y becomes, instead of the y will now go here, like it did here, but it would be a negative y and an x. Okay, so each coordinate flips, as in their reverse coordinates, but the y is negative. Okay, so that, to me, is not the easiest way to remember these, but when you can't really turn them as much, it is one of the easier ways. All right, so now I'm going to, in a different color, do 180 degrees counterclockwise. Okay, so if I take this original point again, I'm going to stick with that original point, and then go, I turn 90, whoops, turn 90, and then I turn fully upside down to 180, okay? So now where is that new point? And remember, this is now the negative x. You kind of have to ignore the numbers as far as them being positive. This would be the negative x, and this would be going down, so this would be a negative y. So now this coordinate is -3, -9. Okay, so the new coordinate is -3, -9. Okay, so I'm going to graph that. So -3, -9 this was 180 degrees counterclockwise. Okay. And we can kind of look at the rule again. Okay, and in this one, the rule, and you'll notice that x and y did not switch order. The first number is still 3, but now instead of being a positive 3, it's in the opposite direction. So it's a -3, so it became negative x. And the 9 became a -9, so negative y. Okay? Okay, and now our last type of rotation will be that 270 degrees. Sorry about that. Okay, so one more rotation in this direction. Okay, and we're going to do 270 degrees counterclockwise. Okay, so now if I take this and I go, and I realize that I could go 90 degrees clockwise, so, but for now I'm going to kind of go 1, 2, 3, so that third one is up, and now we're over here. So you'll see that's at +9, -3. Okay, so this one is at +9, -3. Okay, so this is 270 degrees counterclockwise. So the rule here is now when I started, I forgot to actually put it in there. So +9, -3, +9, -3 right here. So 9, -3, and this is 270 degrees counterclockwise. Okay, and so now my rule, when I start x, y, you'll notice that again they switched. So again, the number that was the y is now the x, and the number that was the x is now the y, but switched around the sign of the y. So in this case, it would now be y. I mean, sorry, you switched around the sign of the x. Well, the original x and the new y. So negative x. Okay, so xy becomes y negative x. Now, I can show you, I'm going to mention this and then I'll kind of show you to prove it, but if you would like to, if you feel like you're pretty comfortable and you want to just try some problems, that's fine. Most of the IXL kind of switches around, and you can also do, I'll put on a PDF as well, so you can try that one if you prefer, but most of that is in figure form, not as much coordinate. So I just want to mention here that since we said that 90 degrees counter was the same as 270 degrees, oops, not 27, 270, there we go, degrees clockwise. Okay, so if we're going to do a rotation, I'll show you that in just a second, that it would be kind of the same. In fact, I probably might as well just do this up here. So, let's look at this up here. We'll just reuse this thing. That makes sense. All right. All right, so, okay, so this would be 270 degrees clockwise. So let's look at that. So here was the original, right? And now I'm going 90 counter. This would be 270 degrees clockwise. So looking at my orange, 1, whoops, sorry, 2, 3, you'll notice that I am at -9, +3, which is still that same one. Okay, so now I'm going to show the same thing for the green point. So 180 counterclockwise, excuse me, is the same as 180 degrees clockwise. Okay, and again, looking at the orange up top. So we go, now we're going to go clockwise instead, so the way the clock goes, 1, and then 2, that's your 180. And you'll notice that orange is down at 3, or negative 3, excuse me, negative 9. Okay, where that original green was. Okay, so you'll notice that that's the same. So you can kind of do either one if you would like, as long as you remember it. And then the last one, of course, when 270 counterclockwise would become 90 degrees clockwise. Okay, so I have this right here, which is at 3,9. Instead of rotating the whole way around to the 270, I'm just going to go this way for the 90. And I'm just going to end up right here at 9, negative 3. Okay? So hopefully that helps with kind of the initial rotations. And then you can kind of stop this and look at the other video if you'd like and kind of get a handle on it, or start to practice some of them and then come back and look at the other video, which will kind of show some different examples of rotating shapes. All right, have a good day. Bye.